Assalamualaikum warahmatullahi wabarakatuh. Our group will be presenting on the importance of modeling in actuarial works, traditional versus AI model. These are our group members.
My name is AMIRA binti ZAWAWI and my matrix number is A203075.
My name is NABILAH binti ABDUL, number matric A202983.
Assalamualaikum. My name is NURFARRAH binti AZMI with matric.
My name is ERINA SHAFIAH binti AZIZ, matric number A202725.
My name is ANISAH binti SAZUAN with matric number A202665.
Hello everyone, my name is ALYA BATRISYIA binti IRFAN and my matric number is A213278. Today, I will introduce the contrast between traditional computational models and artificial intelligence AI models and why that distinction matters for businesses and technical teams. Historically, systems relied on explicit rules and domain expertise to process information. Over recent decades, the field has shifted toward data-driven approaches where models learn patterns from data rather than relying entirely on hand-crafted rules. Traditional models use predefined rules, deterministic logic, and classical statistical techniques. They are transparent, predictable, and often easier to validate, but can struggle with complex, unstructured problems or changing conditions. AI models, especially modern machine learning and neural networks, automatically extract patterns from large datasets. They can handle complexity and unstructured inputs, enabling tasks like image recognition, natural language understanding, and predictive analytics. Key differences include how they are built, explicit programming versus data-driven training, the level of adaptability to new data, and the degree of automation in decision-making. AI tends to be more adaptable but can be less transparent. Choosing AI or traditional approaches affects efficiency and scalability. AI can improve predictive accuracy and automate complex tasks, potentially delivering a competitive advantage, though it may introduce new risks and costs. Adopting AI often requires organizational change, new workflows, data infrastructure, governance, and skills such as data engineering and model governance. Traditional systems may require less change but can limit innovation. This report will compare the strengths and limitations of each approach, present representative use cases, and discuss likely future trajectories to help stakeholders make informed strategic choices. Now, I will discuss how AI and machine learning are changing the actuarial profession and what that means for practice and governance. The profession is undergoing a profound transformation as AI and ML are integrated into traditional actuarial workflows. The central debate is, should we replace conventional methods outright or use AI as a complementary tool? For decades, tools like GLMs, survival models, and life tables have been industry staples. Their value is a solid theoretical foundation and high interpretability, which helps secure stakeholder trust and meet regulatory requirements. However, these methods are largely optimized for structured data and can struggle to detect complex, non-linear relationships present in modern datasets. AI and machine learning excel at extracting patterns from both structured and unstructured data. They often improve performance on tasks such as risk classification, claims prediction, and granular pricing. That predictive power comes with challenges. Many AI models are black boxes, making it hard to explain decisions to regulators and policyholders. There are also real concerns about data governance, algorithmic bias, overfitting, and accountability. The optimal path is a hybrid approach. Combine AI's predictive strengths with the transparency, governance, and judgment of traditional actuarial practice to innovate safely. Concretely, implement explainable AI techniques like SHARP or LIME, use assemble models that pair GLMs with ML, enforce model governance and monitoring, deploy AI in stages starting with lower risk applications, and invest in upskilling and cross-functional teams.
Next, I will explain the main factors or causes that contribute to the growing tension between traditional actuarial models and artificial intelligence in insurance industry. One of the main drivers is the rapid growth of big data. Insurance companies now collect large and complex data sets such as telemetric, wearable health data, and also digital transactions. Traditional actuarial models were not originally designed to handle such high volume and unstructured data, whereas AI models are much more effective at identifying patterns in these datasets. Second important factor is technological advancement. With the development of cloud computing and high-performance computing, it has become much more easier and more practical to implement AI and machine learning models in real-world actuarial applications. And the third one is there is increasing pressure for higher predictive accuracy and competitive advantages. Even small improvement in risk prediction can lead to significant financial gains, which makes AI models are very, very attractive and accurate to insurers. However, traditional actuarial models still play an important role. So these models are based on simplified assumptions such as linear relationship and independence, which may not fully reflect the complexity of the real-world insurance data. At the same time, number five, regulatory and ethical requirements also influence the model selections. Regulators generally prefer traditional models because they are transparent and easy to interpret, while AI models are often seen as black boxes. And finally, number six, there is a growing skill gaps in the actuarial professions. Model AI techniques require knowledge in programming, data science, and also machine learning, which not all practitioners currently have. So in conclusion, the tension between traditional and AI models is driven by the data growth, technology, accuracy demands, model limitation, regulation, and also skill differences.
I will present the impact of AI in actuarial modeling. AI brings both opportunity and challenges to company and the insurance industry. First, improve predictive accuracy and efficiency. AI can analyze large and complex data set quickly. This leads to more accurate risk assessment and pricing. It also improves underwriting and enables personalized insurance products. As a result, firm can gain a strong competitive advantage. Second, transparency and interpretability challenges. Traditional models such as GLMs are clear and explainable. However, AI models are often considered black boxes. This makes it difficult to explain decisions to regulator and stakeholders. Therefore, there is a need to balance accuracy and explainability. Third, bias and fairness concern. AI use historical data, which may contain a bias. This can lead to unfair or discriminatory outcomes. It also raises ethical and legal concerns. Therefore, it is important to ensure fairness and accountability. Next, changes in actuaries' roles and skill set. Actuaries must learn data science, programming, and machine learning. Their role is shifting from model building to model interpretation and validation. This results in greater integration of technology and actuarial expertise. Continuous learning is therefore essential. Finally, model validation and governance challenges. AI models are complex and harder to validate. There is a risk of overfitting and instability. As a result, strong model governance and monitoring are required. The importance of documentation and actuarial principles must also be emphasized.
At the individual level, actuaries are adapting to AI by using a hybrid modeling approach. Instead of replacing traditional actuarial models completely, they combine them with machine learning techniques to improve prediction accuracy while maintaining transparency. In addition, actuaries are learning new skills such as data science, Python, and AI. Next, insurance companies have adopted AI through structured governance frameworks. They focus on transparency, ethical AI practices, and model validation. Many companies also use explainable artificial intelligence or XAI to help understand how AI models make the decision and to ensure that this decision can be justified to stakeholders and regulators. Regulatory authorities take a cautious but supportive approach towards AI adoption. They require transparency, proper documentation, and model validation before AI models can be used in important actuarial functions such as pricing, reserving, and financial reporting. This helps ensure accountability and reduces potential risks. In Malaysia, Bank Negara Malaysia oversees the use of advanced technologies through the Risk Management in Technology or RMIT framework. The guidelines emphasize accountability, data integrity, and risk management. This allows financial institutions to adopt professional organizations such as the Institute and Faculty of Actuaries and the Society of Actuaries provide guidance on the ethical use of AI. They encourage actuaries to uphold principles such as fairness, transparency, and professionalism while also promoting continuous learning and the development of industry best practices. In summary, different stakeholders have adopted complementary approaches to AI integration. Actuaries focus on skill development, companies emphasize governance and explainability, regulators ensure accountability, and professional bodies provide ethical guidance. Together, these efforts support the responsible use of AI while preserving the strength of traditional actuarial methods.
Moving on to what we have learned from actuarial knowledge regarding modeling. First, we must balance model accuracy with interpretability. Traditional models like GLMs are valued for transparency, while AI models often function as black boxes. Actuarial knowledge also emphasizes that models must not only produce accurate results, but also be explainable to stakeholders. A model's usefulness is determined by its ability to support informed decision making. Second, we see the continued relevance of actuarial judgment. AI relies heavily on data-driven approaches, but data alone is insufficient without proper interpretation and contextual understanding. During periods of economic or environmental uncertainty, professional judgment is necessary to adjust models and assumptions. Third is the significance of model risk management and validation. With complex AI models, rigorous testing, sensitivity analysis, and ongoing monitoring become even more critical to ensure reliability and prevent overfitting. Fourth, the growing use of AI highlights ethical responsibility and professionalism. The potential for AI to introduce bias or unfair discrimination underscores the need for actuaries to act with integrity, ensuring that pricing and underwriting decisions do not disadvantage certain groups. Finally, this evolution demonstrates the necessity for continuous learning and adaptation. Actuaries must expand their skill sets to include programming, machine learning, and data analytics. This does not replace actual knowledge, but rather complements it.
Now, I would like to present our group's recommendations regarding the integration of AI in actuarial modeling. First, we recommend the adoption of a hybrid modeling approach. Rather than replacing traditional actuarial methods completely, AI should be used as a complementary tool. AI models are highly effective in improving predictive accuracy and identifying complex patterns within large datasets, while traditional models provide transparency and regulatory compliance. Combining both approaches allow actuaries to benefit from the strengths of each method. Second, it is important to enhance model transparency and explainability. One of the main concerns with AI is the black box problem, where model decisions are difficult to understand. To address this issue, organizations should invest in explainable AI or XAI techniques. Tools such as SHAP values and sensitivity analysis can help actuaries interpret model outputs and justify decisions more clearly to stakeholders and regulators. Third, we recommend close collaboration among industry practitioners, regulators, and professional bodies. Clear guidelines and governance framework should be established to ensure the responsible use of AI in actuarial work. At the same time, these guidelines should provide enough flexibility to encourage innovation and technological advancement within the industry. Lastly, it is crucial to uphold the ethical standards and fairness in modeling practices. AI models should be regularly monitored to prevent bias and discrimination in decision-making. Maintaining fairness and accountability is essential for preserving public trust and aligning with the professional principles of actuarial practice. In conclusion, artificial intelligence is transforming the actuarial profession by enhancing predictive accuracy and enabling the analysis of complex data. However, traditional actuarial models remain essential because they offer transparency, interpretability, and compliance with regulatory requirements. Therefore, a hybrid approach that combines AI capabilities with traditional actuarial methods provides the more effective solution. By adopting explainable AI, strengthening actuarial data science skills, and maintaining strong regulatory oversight, the industry can embrace innovation while ensuring reliability, fairness, and public trust. Ultimately, AI should serve as a supportive tool that complements professional judgment rather than replacing it. That's all from us. Thank you.